Well, good morning, everybody. It is the June solstice, which means in the Northern Hemisphere, this is called the summer solstice. And it's kind of a neat thing to talk about. So let's just do this real quick. You can see the day-night line. We call this the Terminator running across the world here. And it's at its greatest angle that we're going to see it in the year with respect to Northern Hemisphere daylight hours. So what's going on here today is that the sun is stopping. That's what that means, solstice, sun stop. And what we're stopping is its northward progression from the equator up to the Tropic of Cancer, where its rays will be direct. So that's where the rays are going to be direct today, the Tropic of Cancer. That's something kind of interesting, by the way. If you are north of the Tropic of Cancer and you've never been technically into the tropics, which would be between 23.5 north and 23.5 south, then you've actually never experienced direct sun. In other words, directly overhead, 90 degrees, perpendicular to the surface. But you can get longer and longer and longer daylight hours the farther north you go. This is kind of a neat thing about the way the two large spheres, one emitting light, one receiving light, are going to work. Now, the sun has been up already for 3 months in the northern hemisphere. It's been down. Let me rephrase that. The sun has already been up for 3 months on the North Pole, and it has been set for 3 months on the South Pole. But we do start beginning tomorrow with a very, very slow loss of daylight hours in the northern hemisphere, and they begin to gain them in the southern hemisphere. If you're north of the Arctic Circle today, we got 24 hours of sunshine. It's a pretty amazing, astronomical event. But that also means astronomically spring is done. Okay. So we're moving into summer weather, and I want to talk to you about summer weather patterns because we are in one right now. I mean, take a look at that. Large ridge in the west, we know where that's going. It's going east. Okay, this is upper level flow. Hyper local but massive thunderstorm events like the ones coming off the mountains. Look at the ones that were in through parts of the plains, run right down through that boundary. Southeast was hit hard yesterday with more hyper local, heavy rainfall, while the northeast got this round of severe storms that went through. In fact, we've had multiple rounds east of the Mississippi of wind damage, while west of the Mississippi, a lot of hail. I'll show you that all in just a few moments. And as we watch the evolution of the trough ridge pattern, maybe some long wave blocking in the Atlantic, many of us are going to feel like summer just came on full force. But I do want to point out a couple things about this animation. If we zoom in here on the southwest, there are a few large fires that are burning. We need to keep an eye on. One that's just south of the U.S. border here with Mexico. We have another one down here in Arizona, large fire here in parts of Utah. And we just need to keep an eye on these because they are certainly being fueled by stronger winds. We certainly have very, very dry and hot conditions, definitely down here in the southwest United States. And in the meantime, just huge. Look at these storms. Look at the shadows they cast late in the day. These are just anvil shadows, absolutely massive thunderstorm events that are going through the midsection of the country lately. Now, I want to show you where that smoke is going to go. We're just going to look at a 48-hour forecast, just kind of getting an idea on where air quality may be an issue or where upper atmosphere smoke may also, just change the color of the sky and make certainly an impact on temperatures. But you can just see here quite a bit of smoke still coming out of the western U.S. There's still more coming out of the parts of Canada as well. We just need to keep an eye on. Okay, I mentioned that hail. I wanted to show you the last 7 days of it. So this is radar estimated maximum hail size, and we see that a lot of the plains has been hit hard with some very large hail. As I mentioned, we've also had some pretty nasty wind damage events. This was on the 19th. Just take a look at parts of the mid-Atlantic into the northeast where some of these storms went ripping through with incredibly fast winds, 60 to 80 miles an hour. Meanwhile, we did have some stronger winds that came out of Oregon into Idaho and Montana. More hail, though, out of the storms here in the north central United States. Again, stronger winds too, like especially right down here in Iowa, but a lot of hail. I do want to update you on something Matt talked about yesterday. There's going to continue to be a lot of surveying of the damage that was through the eastern Corn Belt from the system that came through on the 18th. This was something else. These winds, I think, knocked down more crop than we know just yet, and we're going to continue to see those surveys come out, and we're going to try to understand if there was truly green snap across a broad number of acres, or if the corn was able to or will be able to turn itself back up. And some of the heat that's coming in this area will kind of give us that idea, but that heat will likely be more of a stressor event on this crop, which was just wind stressed. I mean, wind stress is the wrong phrasing. I mean, it was knocked over by wind, very, very powerful winds. And I just want to keep you up to date because they're now up to 563 reports of severe weather on that day. compared to when Matt just showed it to you yesterday. We get more reports coming in with time. So it's up about 200 over what he showed yesterday. All right, so just looking at where we've had some rainfall. This is the last 72 hours of observed rainfall from our radar and rain gauge network put together in the MRMS data set. And as we look at it, a lot of streaks. And I just want to highlight a few things. You look in the upper Midwest, the northern plains, the Corn Belt. It is important to note that there were the map. You step back and blur your eyes like, there's a lot of rain. But it's hard sometimes to see because of the way I've built my color bar that there are many locations that got nothing out of this. And streaky storms, that is the name of the game for summertime pattern. That's the same kind of story if you come into the southern plains. You get up here into this part of Kansas, which was hit repeatedly with severe winds and large hail in the last 3 days. And Oklahoma, and then get a little south of it, those large storms I showed you on satellite, locally they put down heavy rains, but it wasn't widespread. You can also see, mid-south getting into the southeast. In fact, let's just take a quick look over in the southeast. I've mentioned several times, I have a real good friend down here who works for Nutrien. His name's Rocky. And he just texts me every time another storm comes into his area. And I love it because it helps me keep an eye on this. But I'm telling you, there are places throughout the southeast that completely missed, while I've seen multiple videos of flooding in into parts of North Carolina. So it just iterates the fact that this summer transition is one where our convective events dominate the rainfall delivery, and it's hyperlocal, as I've said many times. All right, where are we today? Well, this was the current all hazards weather map early this morning, and a lot of the coloring you see on this map either does with heat and wind, or in some cases, fog and snow. So it's a very interesting setup here. We do have winter weather advisories that are out for the Rocky Mountains. To the south of it, widespread wind risk, inducing fire here in parts of the Southwest Great Basin. Excessive heat watches and warnings here, but also throughout the Midwest as we get our first sizable summer heat wave that's moving through. And I think you know where I'm going to take this. Overall, I'm still in this position of trying to understand these two features. We have a massive and expansive Bermuda high. I mean, there are multiple components to it, and we're going to watch as some of this Bermuda high flow sets up maybe more over, like I said earlier, the week in Nashville. Pacific high is sitting somewhere here. And in the middle, we're still seeing wide open transport of not only moisture, significant heat, but very, very strong winds. Now, if you miss the moisture side of this, the heat combined with these very strong winds are going to give us very high evaporation rates. And yes, there will be some Saharan dust coming in this pattern over the next 10 days as well. You don't see a Hurricane Eric, which was absolutely a monster yesterday. Matt talked about it coming into Mexico, but we're going to talk about its moisture, excuse me, in just a few minutes here. But thinking about all of this, I want to show you the maximum accumulated wind gusts we're expecting just over the next week alone. So this has already played us through the weekend into early next week. We'll just take it out there about a week. And this is why we have the red flag warnings here. This is going to be an area that's going to have very high evaporation rates because of strong, dry wind that in places, farther west you go, the drier it's going to be, and also just the heat that's going to be on this crop. So what I'm very concerned about with this particular pattern is this map. So what it shows is, according to the National Digital Forecast Database, the expected evaporation over the next 7 days. And we see that some of these numbers are here, possibly getting up approaching 3 inches in places with those strong winds. Now, I started working on a couple of things yesterday I want to just show you. We're going to get these live up on agweather.com. But in addition to just looking at temperatures, we're going to start to derive 2 other variables from this and map them out. Today's extremely hot in the Central Plains, 103, 105 in parts of Nebraska, South Dakota. This heat is going to expand east with time while the west cools down. I mean, look at this cooler weather in the western United States. That's how things shape up on Saturday. I mean, we're going to see 90s getting all the way into parts of, north central Minnesota, northern Wisconsin, possibly touching the UP. And then we're going to see it on Sunday continue to spread throughout the Great Lakes and Northeast with these very hot temperatures for this time of year. On the backside of it, though, there's a big low that's going through Canada. It's going to be dropping rain, desperately needed rain throughout the Canadian prairie, which we'll take a closer look at in a few moments. But overall, that's Sunday into Monday. The cold front sweeps through the northern tier of the United States. So yes, just looking at high temperatures alone, from today to Monday, there will be a 30-degree swing in high temperatures in this part of the United States. As we go forward, this is Tuesday into Wednesday. Look at the heat staying anchored here as the Bermuda high sets itself up over Nashville. We're going to be watching for this kind of ring of fire precipitation pattern setting up, which we're going to get into some more details on in just a few moments. But here's the products I want to show you, and I'll get them up on AgWeather so you can see them. This is a 7-day forecast of total growing degree days. Now, to be clear, I do not include temperatures above 86, and we set a base threshold of 50. So when you look at this, some of these places are actually maxing out on, on 7 days worth of GDD accumulation. So these numbers are very high, and this follows what has been a very cool mid-May to mid-June time period. And on top of that, we're also going to keep track of something called stress degree days. So this is where you take any temperature above 86 and start adding it up. So let's just do an example. If today's temperature was 90, wherever you are, if the base temperature I'm using is 86 Fahrenheit, you'd accumulate 4 stress degree days today. So over the next 7 days, what we're looking at here is the accumulation of those stress degree days. And just to be clear, there's been some research done in Iowa that suggests if you collect more than 140 of these in a season, then you start to see yield loss. So to see these numbers so high just tells you the magnitude of this heat wave that's coming through the midsection of the United States. Now, we got big questions. How long does it last? Now, let's get into that and try to answer that question. First of all, I do want to point out that if we look at 3 different layers of soil moisture, this is the top 4 inches or top 10 centimeters. While still the soils are saturated, look at this broad area of saturated soils here. There are pockets of very dry conditions already developing in the plains, back to the Texas and Oklahoma Panhandle, pockets throughout the I-states, and then very much so in the northwestern United States. Now that's top 4 inches. If we go down to 40 centimeters, which is the top 16 inches, we see the same pattern, right? Even down deeper, down to 100 centimeters, about 3 feet. This is just looking at these vulnerable areas that are, as Matt showed you in the drought monitor yesterday, susceptible, right? So thinking this through, let's just keep on the temperature narrative for a moment. There's our next 5 days. We've kind of seen that in the NDFD data. If we play this out day 5 through 10, there is this cool down that's going to try to take shape. And I'll show you what's going on here in just a second. But watch this region here. As I go from day 10 out to day 15, we start to see more broadly warmer conditions building back in. And this didn't really get a break from it. And it's got me really thinking hard about that particular region, because when you look at the next 15 days, I see very long standing waves, it seems like, in the atmosphere. Do you see those? Now, we've been watching them all week. We're going to talk more about Europe in a few minutes with this one, but this seems to be a bit more of a permanent feature. Well, let me rephrase that. A persistent feature in the next 15 days. And I want to be thinking hard about what that particular feature might be, because the month of July, as we've shown you for the last 2 weeks, right, the European weeklies have this idea about just central U.S. back into the Canadian prairie, back into the Northwest, heat, and some sort of early onset monsoonal flow. And we've got to look at this pattern and try to figure out why and how it gets there. So if you just look, I mentioned a moment ago, from mid-May to mid-June, this area that we're forecasting the heat has been cool. We've assessed this a lot, right? We know that crop is very behind in certain key areas that are about to take on a tremendous amount of heat because of this wetter and cooler time frame. Where was it hotter? Florida, Louisiana, Texas, and the Southwest, pockets in the Northwest. And now what we're seeing is a reversal, right? This is all going over cooler, and this is what's taken on all the heat. So I got asked many times this week about flipping patterns, right? And because so much of the end of May was cool, and I've got a lot of that in what we call the Corn Belt, right in through here, not into the Northeast as well, but the Corn Belt, we're going to do that analysis. I went back to 1895 and I did this. I made a scatter plot of temperature anomalies in May versus temperature anomalies in July. Now, I realized that I misspelled this because I did this quickly in Excel this morning. I don't know what an anomalies is, but I've just a typo. Don't need to comment on it. All right. Now look at this. The x-axis is July. So these would be, if you have a dot over here, hot Julys, cool Julys. This y-axis would be hot Mays, cool Mays. Now what I'm looking for is how often do we do this? That would be a hot July that followed a cool May. See that? And it's a bit rare. It's not like it's happened, but it's not like this guarantee like, oh, pattern's just going to flip and we're going to have, absolute chaos with respect to temperatures after keeping a crop away from early season heat, just dumping heat on it in the middle of its most critical time period, which is what, of course, we call pollination, right? The other thing, too, is you look at it, it's basically just a buckshot, scatter shot. We don't see strong correlations. There is a trend line to it, and it does look something like that. So technically, if you have a hot May, there's a better chance of having a hot July. But the better chance I mentioned is quite small. But it brings me to some important research, right? Stress degree days, that concept and early research was done by numerous people, but one most notable was Elwin Taylor. He found above 140 in Iowa, you start to lose yield. I got a little curious about this, though, back in December and decided to shove some data from Illinois in it. I was just sitting in an airport thinking this through. And so I wrote, with the help of some artificial intelligence, I wrote what's called a convolution neural network model with a little bit of feature engineering on data from 1981 to 2024. And I wanted to know, for counties in Illinois, what variable is more important, the heat or the drought? And the model basically told me this: if you wanted to construct an algorithm that looked at the yield anomalies, you better put more emphasis on the heat than the drought. And it's not just heat in itself, but it's the number of consecutive days of both hot days above about 94, 95, and hot nights above about 74. The consecutive dry days was not as important. It was 30% of the metric, whereas 70% of the metric was heat. And if you accumulated more than about 45 of these units, we didn't find an event where we didn't have yield loss. So these temperatures are critical. Now, because the heat is coming into the central U.S. first and the Northeast second, I just wanted to show you some historical data about the central United States. Is this warm-up, this trend, it's pretty small here that we've seen since 1980. How significant is it? Well, we had a much bigger buildup in the early 1900s to about the 1930s. But I want to show you a lot of this trend you see here in these central National Weather Service region for average temperatures in July is mainly a minimum temperature trend. It's greater for the minimum overnight lows than it is for the daytime highs. Just something to consider here. The daytime high curve is almost flat in this area. But the point behind doing this is I wanted to take these really hot years we've had. I'm not going to go back to the 30s because it's hard to do a historical reconstruction of the atmosphere back then. But I'm going to take these hot years that we've had lately, and I'm going to shove them into a tool that I use all the time to build maps like this. I don't think I'm going to surprise anybody, but if you look at these years, here they are, of really hot central U.S. weather. There was a big ridge. Now, where's our current high pressure cell? It's going to be more east of this, right? But we have the triple ridge. There's 1, there's 2, and there's 3. All right. Now, with that being set up, I also want to point out there's also a ridge here over the Black Sea into the Russian wheat belt that we have to pay attention to as well. Now, with that particular configuration, I do want you to stuff a year in the back of your head. And it's this year right here, 2006. My last 2 slides are going to be that, 2006. We'll come back to that. But you say, well, what were the ocean temperatures doing? Well, they were very cold in the Gulf of Alaska, cold in our PMM region, and there was a fading La Nina with a lot of warmth north of Hawaii and a lot of warmth here off Nova Scotia. That was the most common ocean temperature pattern in July. You then might say, well, what was the sea level pressure doing? Where was that Bermuda high? On composite, it was way over here between Ireland and Iceland, and the Pacific high was directly north of Hawaii. And so that if you say, Eric, what is it going to take to keep the West cool, the central U.S. to the Northeast hot? This is it. Like that is the story right there. Now, do we have it? Well, some of the models are trying to do this. I mean, take a look at it. Matt and I have showed you this repeatedly, and we have also told you that our confidence right now in the European model is not overly high on its seasonal prediction. We've modified it, right? We've thought it through. Matt did an incredible job yesterday of doing that. I hope you got a chance to watch his video. But right now, what is this showing? This is this, July 15, July 22. This is this mid to late July time period. And what is it doing? Well, this is a map of pressure, so the color coding tells you anomalies. It's creating higher than normal pressure here. All right, that's something you got to watch. It means that the Pacific High may have a bias toward the Aleutian Islands. It's also saying that the Bermuda High may have a bias over toward Ireland and Iceland. Now you're going, Eric, you just said that I got to worry about that. Listen, yeah, we can worry about it, or you can realize the fact that the atmosphere has outdone every one of these subseasonal forecasts. And so can I just do this? Low. I want to be very clear about this. I've got to see more signals before I make a call on some sort of chaos in the middle of July. But just take a look. Look at what it's doing. That's the 30-day temperature pattern. Hot Black Sea, hot across northern China, Mongolia, hotter in the Central Plains, Canadian Prairie. And that's what that pattern gives you when you look out there, during that time frame. Now, we are missing a key component to this. This is why this is so difficult. This is an animation over the last 90 days of ocean temperatures. And I imagine a lot of you know what I'm going to say we're missing. We've got all the heat in the world here in the North Central Pacific, but it has bled into the Northeast Pacific. And up until this point, when you look historically, it's very, very challenging to get all of your heat and dryness just to anchor in the central U.S. or in the Canadian Prairie when this isn't cold. There's just a lot of historical precedence that says you're going to need that as well. Now, doesn't mean there's not some new configuration in the atmosphere that we have not seen yet. Oh man, we don't. Our sampling of the history of the atmosphere's behavior is just a sliver, right? But of that sliver, we can go back quite a number of years and just haven't found it. If this was going over cold and I just was showing you blues in this area constantly, this narrative today would be much different. I would have a much more somber tone, and I'd be telling you, prepare, get ready. But we're not there, okay? So there's another way to look at ocean temperatures. We don't just have to look at them compared to historical past. We often look at them compared to today. So this is, read the title with me, surface temperature anomalies. It's a difference from today's global mean, not the historical global mean. So I'm looking to see if relatively speaking, this water's cooler. And you start to see some of that. But man, that's a surge of warmth into that area we have got to consider. And that's not the only player in town, right? Look at the warmth that extends here. And we've got some cooler than average water still there, which gives us this, someone put it in the comments the other day. By the way, I read every comment. I love them. But this sympathetic La Nina setup, I like that. It's a neat way to think about it. But overall, it's all going to boil down to our big positions on the Bermuda High and the Pacific High. And here's what it looks like. This is 15 days of Bermuda High positioning. Let's just stop it right there. Even after 15 days, you could still make a case that there is a large area of high pressure. So flow is coming around, and lows just keep tripping their way through the northern part of the westerly wind belt. And the only thing I'd have to tell you is this. If we lose this and this becomes dominant, then I'll start saying this is not good. If that becomes the dominant position of the high. But there's still a component of it there. And there's still flow like this. And until that goes away, I can't make a call on major drought episodes. But I'll tell you this. Through this weekend, look, there's your Nashville high right there. That's Monday morning. It'll be sitting over Nashville. If you get a chance, go outside, look up. You might see a big blue H in the sky. It's going to be sitting right here. And the effect of that is this. If we were to lose the Bermuda High, what we would also lose is the net position of the jet stream. It would go way up here into Alaska, live way up here into Canada, and then enter northern Europe. And we would get very, very weak flow in the atmosphere in this subtropic to mid-latitude range. And that's why we continue to monitor this. Where's the subtropic to mid-latitude range? It's right there. Well, technically, it's more like here. So as I look at it, this is why I'm telling you, I'm going to be watching to see if over the next month, that shading of color just continues and this drops. And if that occurs, then yes, we will have an entirely different story about midsummer heat coming in. That's what we're paying close attention to. Now, here's the one thing that we must consider in terms of this drought heat risk. There is tremendous amounts of moisture that have already been laid down into the atmosphere through this region, into the Northeast. The West has been drier. This part of the Corn Belt has been drier. But we can't argue with the fact that we have got some places here that since April 1 are 200 to 300% of normal on precipitation. Now, you can just as easily say, wow, look how dry it is in this corridor here along I-80. Look here. And yeah, this area got some rain, streaky, but some rain in the last few days. But if you want to look at it in terms of totals, let's just zoom in here and have a closer look. In fact, no, let's do something different. I'm going to instead show you this. Let's zoom in this way. This is departure from average, April 1 to June 18th. So I have some places down here that are 12 to 15 inches wetter than normal, and some places in through here that are 3 to 5 inches drier than normal. Maybe a better way to look at it in terms of percentages. So there are still parts of Nebraska, Iowa, both sides of it, northern Illinois, Wisconsin, Michigan, northern Indiana, Red River Valley, that are sitting at 30 to 50% of normal. You want to see the departures a little bit more closer. Look at these numbers. So there's some vulnerabilities here that these rains have to fill in, but they're trying to do it. Just look at the radar animation early this morning. So here it is. Watch these storms coming through the Midwest. Nasty storms moving through Iowa this morning, right here. These are going to continue to cascade through parts of Illinois. They're probably going to lose some of their steam as they come through the rest of Illinois. But we could, because of how much moisture is in the system, where did I put that map? There it is. We could get ourselves into a hot and stormy summer pattern rather than a hot and dry one. And here's the Storm Prediction Center's outlook for today. Running across the northern tier of the U.S., you know what that is, right? That's our ridge runners. You then come into tomorrow, they slide over here. So this is the UP through Michigan all the way down into New York. It's going to cut through parts of Ontario as well. And then day 3, this is the big low that's coming through here. It's going to drag a front in through this area, knocking these temperatures down early next week in the northern tier of the United States. Well, along that front, we're expecting some severe storms. If you want to see what they look like, just go to the website, agweather.com. You can play any of these animations. There's that low. Look at the size of that sucker. Going up into Canada. Wow, what an interesting pattern just over the next few days alone. But I stretch it out and look at it like this. You want to see the influence of that Nashville high? There it is. There's the Bermuda high doing its thing. So this is going to be our wettest region. And there's going to be a very tight line in through here where I think if you were to the south of that, the precipitation coming through is going to be very, very sporadic, very isolated. It will storm in this corridor. You will get storms. They're just going to be the pop-up variety. They do not last long. They may blow up downstream as these convective events sometimes can. But overall, that's not a whole lot of rainfall coming with all the heat that's building into that area. Take a look, though, Canadian Prairie. Oh, yeah. Desperately needed rain with this low that's coming out here. So let's do this another way. This is the next 5 days of precipitation anomalies. This is the next 7. But if you just look at day 4 through 10, there is the ring of fire. There's that rain in the Canadian Prairie still showing up. You say put all 10 days together, and that's what the European model shows. Now just be careful. You would be tempted to look at this and go dry. It's not dry, it's drier. There's still going to be daily convective events, pop-up storms in that area. Now, thinking about it, take a look at this. If we go have a quick look at the next 5 days, 10 days, forgive me, on the risk of staying below a half inch, it's central Texas through the Mid-South Ohio Valley into parts of the southeast. It's also dry in the southwest. But see this white that's in through here? That's an area that's expected to be very, very wet, including New Mexico. In fact, let's flip this script and go over to who's got the best chance at an inch. That's the probability of getting over an inch in the next 10 days. Here's 2 inches. Look at that. And if you're curious, that's 4. We're about to hit this area with a lot of wet weather. Same thing down here. And we talked about this before, that the remnants of Eric's moisture plus just the ring of fire setup, we're looking at some desperately needed rains over the next 10 days coming into like Chihuahua, which we talked about as being an area that's pretty dry. Now, if we just step this back out and say, well, are there any more tropical systems developing? Well, right now, through the end of June, some of the models, like the GFF, were trying to toss out tropical systems into the Bay of Campeche, but I don't see it again. But right now, this is our best corridor for any sort of tropical low-pressure system development. We'll keep an eye on this. If that changes, we'll make sure and let you know. So we get out there into week 2, and this is what we see. The AI model and the GFS are better about bringing in more storms Ohio Valley. The European is much drier here and ring of fire there than the other models. And that's something we have to be thinking about and talking about. By the way, remember that long-standing wave pattern we talked about? We still see all across Europe, I mean the majority of it, all the way over Ukraine, Turkey, Black Sea, still showing up quite dry. Russian wheat belt split, wetter north, drier south. Okay, that brings us to kind of the end of this. Where's it all going? Where are these high pressure cells moving? European weeklies going through the month of July continue to show that if we separate those high pressure cells, one here and one there, and if we get a long-standing wave going, we're drier here and we are drier there. But I think the thought process here needs to be more focused. We need to think more about, if we just zoom in on the United States, where is this greatest dryness going to be? And whenever I see some indication of southwest monsoonal moisture, I got to be thinking more about ridge placement. And as Matt pointed out the other day, I think that the greatest risk of where the driest conditions are going to be will likely be in the northwest United States, getting into Montana, possibly the Dakotas. Now, if you remember this from a month ago, this entire area was under the risk of developing drought through summer, and National Weather Service has taken it off the drought development likely, and we've started to see it increase in these areas. And it's because their temperature forecast for July, August, September is hottest throughout parts of the Great Basin into the northwest. So this includes Snake River Valley, Columbia Basin, Montana, just as a few places to name there. This is how they have August, September, October. And this is how they have September, October, November. And I had to chuckle at Matt's video yesterday. He's like, I just wish the CPC would update this. Literally, when he uploaded the video, these were released about a minute and a half later. I was watching. Now, the precip is what's curious. Very wet, dry. Drier. And that gets into the Canadian prairie as well. But this is not nearly to the magnitude of dryness that we saw. That's July, August, September. This is what they have for August, September, October. And do you remember how I told you earlier I want to be watching 2006? Well, this is one of the reasons why. See this area? In 2006, we were drier in the northwest. We were also drier in the southeast. And one of the reasons for that was throughout summer, we had a more expansive Bermuda high. We had a pretty large part of the Pacific high here. So all of the best flow went in between where we put the squeeze on the atmosphere. So that was a summer of major precipitation disparity. The northern plains, Canadian prairie, parts of the northwest, and then pockets in the southeast, that's where we saw drought. And then we watched this here get very, very wet through July and August. And then take a look at the temperatures. It was a hot summer for a lot of us. Now, this is just 1 year, and there is no such thing as a repeating year in the atmosphere's behavior. But I just wanted to give you a preview of what I think we're going to be talking about to finish 1 month and start a new one. And we look forward to giving you those updates. So be safe this weekend with the heat because it is coming on. And just take very much care of your body as this heat comes on and watch that crop. That crop is going to start to show us signs as to whether or not this is truly stressful or if it isn't. And that'll be the question we're going to try to answer. Okay, that's all I got for you. Have a good weekend. Thanks.